Hi. Galileo was the first person to use a telescope for astronomy, and that enabled him to make great discoveries. The first of which is that I will talk about is the moons of Jupiter. There are four moons of Jupiter. These are called the Galilean moons of Jupiter. Io or Io, Europa, Ganymede, and Callisto in order of distance from Jupiter. And we can see from these observations here that the closest one, Io, is orbiting very close and fast. Europa, further out, a little bit slower. Ganymede, still further out and still slower. And then Callisto is the one up here, seen there, traveling the slowest, taking the longest to orbit, and moving the furthest out. All of these things supported the idea that these were in orbits around Jupiter, very much like the Earth is in orbit around the Sun and the other planets are in orbit around the Sun. So this was a strong support of the heliocentric model. And here's a document showing pictures in a letter sent by Galileo of the positions where he would see the position and then see the position again on another night, and there was a slight change in motion, sometimes a large change in motion, depending upon which moon he was looking at. And so this is a time lapse taken over a period of about a day or so, a couple of days. Io has an orbit of just under 2 days, so this looks like it orbits around one time for the innermost moon. The moons of Jupiter were also independently discovered by Simon Marius in 1610, but they got famous because of and got named the Galilean moons. So usually people think of these as being discovered by Galileo, and probably he did more observations and more was learned about the moons from Galileo's observations. Another thing is are the phases of Venus, and so what Galileo saw can be seen in this viewpoint here, that he saw different phases of Venus. When you looked at Venus up close through the telescope, sometimes it had a crescent shape, and it could be on either side of the disk. Sometimes it had more of a quarter shape, half lit, half dark. And sometimes it would be in a gibbous shape, and you really wouldn't ever see a completely full lit Venus because the sun was in the way, but you would be able to see often this gibbous shape. And notice from the viewpoint of Earth, the gibbous shape is small compared to the crescent shape. The crescent doesn't have much of the face that we see lit, but it's much larger, and it's about three times larger than in the crescent shape than it is in the gibbous. And so by looking at that and thinking about what Ptolemy had predicted in terms of the view of Venus as orbiting around in a small circle, he would expect that you would have mostly crescent phases, and sometimes just weird and not visible when it's in line with the sun, which makes sense. But you would always see crescent phases when it was far from the sun, and when Venus is in one part of its orbit, it's considered the evening star because it's quite bright in the evening time, and when it's another part of its orbit, it's quite bright in the morning sky. So it's often called the morning star. So you have a morning star and an evening star. Is Venus at two different times in its orbit. But this was completely contrary to what Galileo observed. However, if we consider the Copernican view of the orbit of Venus, we have exactly what is observed, the crescent being near the Earth and the gibbous being far from the Earth, so the crescent appears large, the gibbous appears small, and the full is not seen, or the new is not seen because it's lined up with the sun. And the same thing over here, the crescent, and then the quarter on each side is because halfway around the orbit you would get Venus with light shining on the other side. And so in the Ptolemy's view, you would never have the quarter or gibbous phases, and so this can completely be ruled out by these observations. So this is a case where a model just cannot survive the test of these observations. Now, we can really say that Galileo's observations of the phase of Venus prove that it orbits the sun and not the Earth, although it took Kepler's determination of the laws of orbits to show that how exactly the orbits work, and that was done really just a few years before Galileo's observations. So Galileo's observations were beginning in about 1609, 1610, and Kepler had presented his laws of planetary motion. At least his discovery is made about 1605 and was published in 1609. So this was very much at the same time. Well, Galileo also discovered sunspots. He looked at the sun. This is a replica of his telescope on the left, and his drawing of some sunspots, and this I'm sure was not good for his vision. In fact, he had poor vision later on in life, but so it's never recommended to ever look at the sun through any kind of telescope. And but that's what he did, and he had some drawings of spots. You can get the same picture by using a telescope and allowing the light to focus on a piece of paper back here, and then drawing on that paper, drawing that reflection off that paper. It's a much safer way. Here are his drawings of the moon as well from one of his books.